Welcome to the second episode of this podcast that we're going to have weekly here in the TheServinLab. Yeah, my name is Christian Servin, and this is the second episode, the podcast. This is Kotlin 101, which will be an invited speaker later on today. So let me just remind you the whole purpose of this podcast is to bring you a couple of concepts, a couple of different ideas. That's what's happening in computing related and emerging topics in computing, not necessarily in computer science, but in technology in general. Brings a couple of emerging topics, emerging areas, and concepts that we want to pursue as not only as a student, but also as professionals. So the whole purpose of this podcast is to bring you these different perspectives. So once you graduate, or if you already graduate, to see where is these ideas or where these areas where you can apply for a job, or maybe to do a little bit of research, or if you want to explore a new area, this is the whole idea of this podcast. And today we have a very nice and exciting topic, which is Kotlin 101. And I call it 101 because it's the very beginning, just to give you an idea what Kotlin entails. And we have a special guest, which is considered to be one of the very first Kotlin's programmers. And you will see why, because it's a fairly new programming language nowadays. And before asking to elaborate a little bit more on Kotlin, let me just go ahead and talk about a little bit about Enrique's background, since he has been in the workforce and industry just for a while. Let me just start right now by just telling you that he's a principal software engineer in a company called Granular, which is helping farmers to run efficient businesses and steward and land for the next generations with mobile technology. I found this amazing when he told me with all the work that he was doing with farmers, but incorporating technology in that is amazing. And I'm gonna let him talk about that later on. Before that, he was a designer and architecture for one of the mobile apps in Capital One, 2017 to 2018. So cooperate on design, architecture, and development of core component features in Capital One mobile infrastructure. And before that, he was the lead system administrator in 2014 in another area in the San Francisco Bay Area. Yeah, in a couple of doing the world's first drag and drop Internet of Things project builder. Before that, he was a research assistant in HyperSys, which is the high performance systems, in 2011 from 2013. This is when he was doing his master's master thesis. Is that correct? I think that's where he had the honor to attend to that to that master thesis. He worked under the supervision of Pat Taylor, which was amazing. It was quite impressive, and yeah, I remember those days when we attend to that. He was at UTEP, the University of Texas in El Paso, and I'm very proud to see the whole work that Enrique he has done through all these years, professionally speaking, as a computer scientist, as a developer, and I'm very happy to have him as one of my best friends, right? So I'm gonna welcome Enrique to this podcast. How are you, Enrique?
Very good, very good. Thank you very much for your welcome and, and all your words. I appreciate it. And thank you everyone who's participating in this podcast. I highly appreciate your time putting on this, and I promise you that it's gonna be the information that I'm gonna give you today is gonna help you at some point in your life if you take it in the right way.
I think so too. I was looking at the presentation before this podcast started, and Kike and I, we were just going through like this. You're covering so many different things that they're going to be super useful for all our speakers or viewers. You're going to talk about Kotlin, of course, as the main topic, but the way you incorporate a couple of your slides, you cover a lot of different aspects in computing, software engineering, development, and also the whole business interest as you have there. Of course, I forgot to mention Enrico. He's in the. Are you in San Francisco or are you in San Jose? I cannot remember.
I'm in San Francisco.
He's in San Francisco, and he's been in that area for a while. He has a lot of experience with many different companies, software companies, and he has developed a lot of nice networking there. And it's a very nice environment because many software engineers, it's like the holy place that you go there and you can see a lot of different people that work in similar projects. But I'm gonna, without further ado, I'm gonna let you talk more because your presentation is pretty exciting, and I'm very excited to see here how you're gonna present that. And let me just go ahead and give you the the power to actually present your presentation. Can you present it right now or not really? Okay, just let me know if you are able to do it. Perfect.
Okay, can you hear me now? Yeah.
Yes, I can hear you. Yeah, I think we can
And
see you also.
True.
Yeah, I think that was a yes.
Okay, okay. And you can see a phone on your screen right now?
I can, yeah.
Okay, perfect. So let's start. So yeah, a super quick round on. I basically graduated from UTEP in 2013, then moved to LA right after in the early 2014. And I took 6 months sabbatical, and then I started working in that startup, IoT startup that Servin mentioned. I stayed there in LA working for them for a couple of years, and then I moved to the San Francisco Bay Area in 2016. Since then, I have been working in Capital One. Started as an Android engineer, and I moved up the ladder to be an Android tech lead and then architecture. And after Capital One, I moved to Granular because farming is something that I'm passionate about. It's a big problem that we have in a world, like the world. It's a world-sized problem that we have, and we're gonna have a huge problem in 2050, where our production of food, as we are doing it right now, is not gonna be sufficient by the number of people that's gonna be on Earth by then. So we need technology to solve these kind of problems. And I think when I joined this company, that was my thesis statement, right? I'm gonna do something that is gonna impact all farming in the US. And that's what we have been working on. I have been working on for them for a year and a couple of months now. So Kotlin, if you have never heard the term Kotlin or the Kotlin programming language before, I'm pretty sure you have used it. If you have an Android phone, it's probably have Kotlin code or Kotlin compile code inside of it. It's widely used in Android at the moment. So first, I want to start with a little bit of history with Kotlin, right? So who and when was created? The Kotlin code, the Kotlin language was created by JetBrains, which is the guys who build your super awesome IDEs. I love all their IDEs. They have like a bunch of them. If you haven't tried them, please try them. If you write in Java, you have to use JetBrains by now. It's something that is used in industry. It's like by default. The project with Kotlin started in 2010. It was open source from the beginning, and the first version, the first release was done until 2016. So you can take this as they really put a lot of effort and a lot of thinking into the programming language, into the paradigms. And until they felt it was production ready and useful, that's when they released it. The reason of why it was created, right? So the guys who work in JetBrains, they had to work on their IDEs, and back then they were using Java to write them. And they realized that using Java, it's just painful. There's a lot of boilerplate code, a lot of bad stuff. So they said like, no, we're gonna create our own, and we're gonna write our IDEs based on that language itself. And that's what they started doing. And they did it actually. So all of JetBrains IDEs are actually written in Kotlin as of today. Huge milestone. This is Google I/O on 2017. I was present right there in that presentation. And it's when Google basically adopted Kotlin as their main programming language for official programming language for Android development. So by 2 years after that, Google announced that more than 50% of professional Android developers now use the language to develop their apps. And in Stack Overflow, it ranks as the 4th most loved programming languages. When I give you a demo today, I will show you why that is. There is a really good explanation for it. I personally started using Kotlin in Capital One back in 2016, even before it was released, actually. I had a mentor there, Aaron Sarasan, an amazing software engineer. Back in Capital One, he was a master software engineer, and he loved to test new technology. He was right, like he's always ahead of the curve, and that's why we started using Kotlin. He's the one who introduced Kotlin to the whole Capital One company. It was because of him, and that's thanks to him I started using this language from my very early adoption, even before Google announced it. These are like, since it was released in 2017 and adopted by Google, all these huge companies have moved their app development to Kotlin now. And you can see huge companies here like Netflix, Airbnb, Lyft, Slack, all of those guys. And if you think about it in an economical sense, like to move all your engineers to learn a new language and then move your code base, which is already working, to a new language is a huge investment. It's almost crazy to think to do that if you're like a CEO in a company. Like, why am I going to spend all this money, right? But I'm going to show you why that how do you say it? That decision was so important and why they actually took it. Also, or their app, they didn't have Java in their apps until we joined. So I'm spearheading, me and the other engineers, so we're spearheading introducing Kotlin and solving all these problems for the company as well. And so pushing this new technology to farmers and help them reach there. So one of the questions is why it was adopted so quickly, right? Taking into considerations that there was already other solutions back then, for example, Xamarin or React Native, which you can also do like your business logic and all the logic actually with one code, JavaScript, and then it compiles to both platforms. So why Kotlin, right? Why Kotlin was such a good? So one of them is when you used to use Java and then you start using Kotlin, it feels like you have superpowers. It feels like when you think of an algorithm, a way to fix something, you can just write a couple lines of code. It's extremely readable. It's very easy to understand, and it does what it's supposed to do. And that's just like, that's how you fell in love with that language. Safer code. If you have used Java in the past, you know what a null pointer exception is and how often that happens. Since, well, in Capital One, actually, 6 months after we moved to Kotlin, we moved to 0 null pointer exceptions. After that, we never had null pointer exceptions anymore. Of course, Kotlin doesn't solve this out of the out of the bag, like you have to know how to use the language in order to not to circumvent these problems. And the third one is, and the one that is extremely important, and the one that the other solutions didn't have at that time, like Xamarin or React Native, is that Kotlin, you can have your whole project in Java, and then you can just add one class in Kotlin. And that class is gonna play well with Java, and you can call Kotlin from Java, or you can call Java from Kotlin. It doesn't matter. So if you want to transfer your app to Kotlin, if it's just in Java and you want to transfer to Kotlin, you can start doing it in pieces. And that's a very nice way to transition. So now I'm gonna give you a small demo of the main basic things that Kotlin does for you. And then you can do more. But right now I'm gonna move to my IDE. This is Android Studio. It's the tool that I use to create Android applications. And I created a little project for you so we can explain some of these concepts. So if you have used Java and you have to create a class, for example, a person Java class, and this person has a name, surname, and ID, and each one of those fields have a getters and setters, as we have been taught to do all the time. And then if you want your object to be able to be comparable, you need to override the equals, the hash code functions from objects, and then also the toStrings, so you can express how you want that object to be printed when you transfer that to a string. So this code, I'm pretty sure you have seen it and you have used Java in the past. It's the boilerplate code that we have ever seen. So if we had to translate this to Kotlin, by the way, before I continue, if you see here at the top, if the file ends in .java, it means that it's a Java file. If it ends in .kt, that's a Kotlin file, just for you to notice. So I'm gonna show you what this class in Java is, the representation of this class in Kotlin, basically. So in Kotlin, to build this class, you basically need to do this. One line of code. The only thing that changes is that you added that it's a data class. You see here that it's nothing super complicated. It still has its three properties. And that's it. Everything else that you see here, it's already created and compiled under the hood by Kotlin. So when you are going to use these two classes, one in Java and one in Kotlin, let me show you how do you use them. Okay, so we have those two types of objects, right? Person Kotlin and person Java. If you want to instantiate a new class of those, this is how you do it in Kotlin, and this is how you do it in Java. The balls, I'll explain that in a little bit, what it means in another example. Right now, the only thing that you should be focusing on is how the object is being created, which if you see, it's very alike than in Java. The main difference here is that this is not a mutable object. You created an instantiation, you added the values, versus Java, you create the object first, and then you assign values to it. Meaning this object in Java is mutable, just because in Java, every field that you have, it's nullable at the beginning, and then you need to set information to it. In Kotlin, the nullability, it's you can get rid of it. You can just say like, this is gonna be information, it's not gonna change ever. This is very good for functional programming, and it saves you a lot of time with when states are changing in your app, which happens a lot in Android. And then this is how you use those objects as well. Person one and person two, toString. If you see, we're gonna see the difference between the Kotlin toString, which was created by itself, and the Java toString, which we override here. So if we run this little application, how it works is gonna show us a button. We're gonna click on that button, and then it's gonna do this and present the two persons on screen. It's building, because it's the first time probably. Yeah. So here on this screen, on this app, it's very simple. We only have two text views, the first one and the second one. When we click the button, it creates the persons and then shows them on the screen with the toString. If you notice both of them, they're exactly the same. But one of them was created automatically at compile time versus Java that you have to do it by yourself.
For those who cannot see right now, is an emulator for the mobile app that he's demonstrating. And the mobile app basically runs those programs in the background. So that's the emulator for this generic phone. Doesn't mean that you have, I think it's a generic phone, right? So that's what we can have.
I'm sorry that I didn't explain that. So yes, when you download Android Studio, it gives you a big range of phones that you can emulate. Right now, I'm emulating the Pixel 3 XL.
That is the Pixel, okay. And,
yeah,
and we're,
you can emulate every phone since Galaxy S5 if you want, or something like that. And it's just for you to be able to write tests and then automatically run them on every platform. So you know that your code is gonna work well on every platform, which is something that you have to do on Android.
Yeah, thanks. Yeah.
Okay, so let's move to the next, nullability and mutability, which is some of the most important things that Kotlin helps you with. And first, we're gonna concentrate on this first line. If you notice, when you create a new variable, you can specify if it's gonna be a val or if it's gonna be a bar. Var by variable and val as value. Values are things that you set once, they're final, and they're gonna stay like that. You can't change them. Variables on the other side are things that you can have an initial value and then you can change it over time. It's mutable.
So is it fair to say that val it means for constants and var for variables? Yeah.
Yes. So the translation to Java, basically everything in Java is a var unless you specify it with a final. So string final name of the constant, that will be a val. But in the switch is that in Kotlin, you mostly use vals. You mostly use final objects and you don't change their state after they're created. And that's big part of how functional programming works. So when you create a new variable in Kotlin, you basically specify if it's gonna be final or you want to change it over time, the name of the variable, semicolon, and then the type of it. This part is totally optional. The Kotlin language, as comparing to this line, which are the same, if you notice in this one, they're the same. You're defining a string, but on this one, I didn't specify that it was a string. It knows that it's a string because of type inference. It already knows, oh, this is a string, so this val must be a string. It's something that is done, I think, in JavaScript or Python and stuff like that. Versus on Java, if you remember, you need to specify string, name of the variable, and then the equals. So you need to specify the type. When you're creating a variable, so for example, here I'm creating the variable in this line, and then on the next one, I'm changing what that variable has. If I try to do that in Kotlin, it's gonna tell me that it cannot, vals cannot be reassigned, right? So it's not gonna let you. This one is very important. This is what it touches. This is the main thing about nullability. So let me explain this. What's the difference between this one and this mutable string? So the difference is that this one, this variable, when you're gonna change it for something else, it has to be a string. You cannot change it for a null, for example. Why? Because you're telling that this variable will always contain a string, either the initial string that you set it for, or if you change it over time. But in order to mark a function as it could be nullable, you do it with this little icon. So for example, this is telling me like this variable, it's supposed to be a string, but we don't actually know. It could be null as well. And these variables, basically you can store a null on them, or you can store a string, like on this one. The beautiful thing about Kotlin, if you notice here in the function signature, it's also a little bit different. Every function starts with fun. You have to declare the visibility of that function. By default, if you mark it like that, that's a public function or private function. The name of the function, any arguments that you want to put here, you put it here, your arguments, and then you, after the column, you have to specify what's gonna be the return type of this function. The return type here is a string, but it cannot, if you notice, it doesn't have this, which means you have to return a string. You cannot just return anything that is not a string. So for example, if I try to return this variable, which could be null, it's not gonna let me. It's gonna tell me, no, you are required to return an actual string. You cannot get something that may be null. This is the powerful thing about Kotlin. And so for example, if you're gonna return something that could be nullable, you need to use this thing that is called the Elvis operator. Elvis because you see the little eyes and the little fang going there. So that's what they call it. And the Elvis operator, what it does is basically saying, if the left side is null, return the right side. That's it, right? And that way you can always return a string, an object. There's no way you can return a nullable object. And that's one of the simplest way to explain how Kotlin gets rid of nullability and all that stuff.
And right? I think if I make a small comment here, I think this is one of the most important concepts, because if you study programming languages, there's some features like readability, writability, if you're strong type, if is, there's a lot of different characteristics that you will learn eventually in taking other classes, in particular programming languages, design of programming languages. And here it combines what they call flexibility to allows you to have multiple parameters to enter, but still strong type because of that condition that Enrique just mentioned here. It says like, for sure, we will return a string regardless. And it checks what is called Notability. Yeah, so because when you create mobile devices apps or mobile apps, you may have or you may not have an input. And this is something that, as he says at the very beginning, this is the problem in many mobile apps. If you just put submit, if you haven't give any information, that crashes most of the programs. And I think here it combines very nicely all those features. Is that right? Yeah.
Yeah, that's extremely correct. So one of the things that I have heard was that people, when they think about mobile development, they think that it's very close to web development. And I cannot emphasize that it's not. Mobile development, you basically, your phone, it's a computer, right? It has a processor, memory, everything, plus a bunch of sensors that you can access to. But in these mobile apps, you have a database, you have internet connection, you have, so it's like a computer basically, and you have to manage all these states that are changing all the time. And that's what Servin was mentioning, that sometimes when you click a button and you want to send something, because so many things are changing at the same time, you don't know if that thing that you're gonna send is ready, it's nullable, or in which state it is. So this is a safer way to build your code so you can get rid of those edge cases.
And I think you mentioned the correct word, safer. And that's something that we cannot emphasize it enough these days. When you create software, it has to be secure code or safe code or robust code. And I think here, considering those multi-factors that you mentioned, when you have something dynamically that keep changing, you have to consider safe code. And that's one of the features of Kotlin as I can see.
Yes, that word actually is the important one, safer code. Now I want to show you optional executions. So in Java, or historically, every time you receive a parameter, an argument, it could be null. So you usually need to check if the thing that you want to use is null. If it's null, you do something. If it's not null, you do the other thing that you were intended to do. But this if-else has been used in Java so much just to check for nullability. If you want to translate this to Kotlin, well, this code is Kotlin, right? But it's basically mimicking what Java does. If you would like to translate this to Kotlin, in Kotlin, you can do it in one line of code using the LB separator. So if this is null, then this, right? And this is pretty more beautiful to read and less boilerplate code that you have to go through. Now, array manipulations. Kotlin has a lot of tooling around lists, basically, how to manage lists and everything. So for example, here we have a function that generates person Kotlin objects, right? And you tell it how many of those objects do you want. One thing that you can notice here is that in Kotlin, you can specify like, this is an argument, how many, but you can also define a default value for that argument. So when you call this generate persons, let me show you right here. This makes the arguments optional. You can pass arguments or you cannot. If you don't pass arguments, it's gonna take the default one. If you do pass something here, it's gonna tell you, you can specify and then it's gonna use the value that you set instead of the default one. That's another little thing that it's nice. Also, when you put arguments, Kotlin already puts here the name of the argument that you set. So it gives you an idea of what that argument means. If you remember in Java, you have to pass like 5 arguments. You don't know the order in which you need to pass them. And sometimes you can pass like an argument that it was supposed to be on the third,
the third parameter, the third position, yeah.
At the third position, but you pass it on the fourth, and that can bring problems. So in Kotlin, it tells you like, this is the name of your argument and how much. And if I put multiple parameters, right. So that's just about arguments. But what I want to show you here is that this is a function that takes a number. It returns a list of these kind of objects. And this is just an example of how to create a list. There's many examples, but this is one of that I really like. If you have a number and you need to create a certain number of objects from 0 to that number, You can first specify, I'm going to return a list that starts from 0 until how many? And then I'm gonna map those numbers that come from this sequence. From 0 to many, I'm gonna map each index, each number, to a person Kotlin object, which right now I'm just creating a person based on the index and nothing important, but basically this map returns a list of whatever object we create here. And
if I can make a quick question there. Obviously, this is a little bit more functional, right? Is that what you're trying to do? A little bit of functional programming? Because you can tell right away that it's not completely object oriented, but there is some kind of functional language. Is that correct, Vic?
Yes, that's correct. You notice in this kind of approach, you're not using mutability, you're not using variable. It gets created and then it returns to you the whole thing.
Is very powerful, and Java tried to do something in the latest versions called the Lambda functions, which is functional language. And I think this is the exact part where Kotlin is super powerful because of these kind of idioms that you can actually incorporate. Can you tell us what the map is? Is that considered to be like a one-to-one, like a hash table? Is that most likely what it is, like a mapper?
A mapper is, so basically this first sequence, this is a sequence, right? From 0 until how many. So this is, you can see this as a sequence, as an array of ints that is gonna go from 0 to how many, from here to 5. And then that array of ints, when you say map, this lambda, what it's saying is that I'm gonna return each of those values in that sequence. And then you're gonna use that value to create another type of value. And I'm gonna create a list of that new type that you define in your map.
Yeah, this is amazing. This is similar when you have seen the range function. If you're familiar with Python, the range is an iterable part, but the only part what you can see in line 74, that's what they iterates through those, but at the same time it keeps associated each index to that value. Yeah. Okay. Thank you for explaining that. I'm sorry to interrupt. You can check the chat real quick.
So let's say this function is being used on here. I'm creating a value, a person's list, and that list I'm gonna generate 4 persons here. If you notice one important thing, this person list is of type list, right? And if I try to add another person after, it's gonna say nope. No, because this is a list. It's not mutable. You cannot change it. It's a list. You cannot change. You cannot add. You cannot delete values. It's functional. But if you need a list to add or delete, like a variable list, you need to do mutable list. It's gonna break because this is not a mutable thingy, but then you can add and delete values from it. And that's the main thing, that by default, most of the objects that you create, most of the lists that you create, if you do them in a static way, there's less possibilities for your code to fail because of different states of your code. So what I'm gonna do here is that we create a list. Now we're gonna use that list. And usually in Java, to do this, we use for loops. I have not used a for loop, I think, in more than 2 years anymore. In Kotlin, you can use for loops. It's there, you can use it, but nobody uses them anymore. Now, for example, to print all these lists of persons, we just use a for each. For each value in your list, give me that value and then do whatever you want with that value in it. If we execute that code, I should see the results here in my logcat. So it's gonna say print each person, and then it's gonna print each person. It's right here. And if you notice, I'm just printing the person object. I'm not even printing that toString or anything. Kotlin already knows that. If it's an object and it's not a string, it converts, it automatically goes to the toString function that Kotlin already created on compile time. Some other things that you could do on your lists, because Kotlin gave a lot of support on lists. You can sort your list, map your list after you sort it, and then for each of those map values, print the surname. So for example, what am I doing here, right? Let me take this out so it's less. What I'm doing here is that I'm saying sort this list, sort it by descending. So start with the highest value and sort it using the name field of that object. Then map those results, those persons in this list. I want, instead of the whole object, I just want the surname. So what this is doing is converting a list of people to just a list of strings, which is a list of the surname of each person. Then after this is gonna give you a list of strings for each of those items. For each surname, just print the surname, and you can see here. So you can, here we are mutating data, but if you do it, we're doing it in a functional way. There's no step in between that the data could have changed and give you a wrong result. Everything is done in a pipeline, and that pipeline is black. You cannot get in or out of it. And the pipeline starts here, the pipeline ends here, and whatever happens in between, you cannot touch it. Now, there's so many things that you can do with lists. I really could not, we don't have enough time for me to go to all the things that you can do with lists, but they added every possible thing that you can do with lists. So list management in Kotlin is super nice, super beautiful. And if you want to do this in Java, it will take at least
a lot of lines of codes, yes.
Yeah, many lines of code.
I'm sure the API is very comprehensive of the Kotlin API for only for lists, because they're widely used. And I noticed that if you see the Python API for lists is quite considerable, but you just mentioned, you just put the dot and shows a bunch of things because it combines a lot of functionality there. I think it's quite impressive what you have on those 1, 2, 3, those only 4 lines of code. I think you can do it. You don't talk about that because in Java, you will have to create objects for each of the database, order them, sort them, of course, depending on what kind of sort of scores, and then do the mapping. I think you're talking about more than 30 lines of code in Java.
Yeah, I'm just being nice. So after that, like if you want to access the first element of that list, it's very idiomatic. You can just read it. Person list at first. It tells you the first thing in that list, or person that last, instead of person list. And then in Java, I think it will be like that. And here you will have to find out the last. I think it's size, right? But if your person list is 0, this is gonna give you a problem.
Negative, yeah.
Yeah, so you need to check the length and stuff like that. If you put that last, that takes care of that.
One of the questions that is in the chat, and I didn't mean to interrupt, I'm so sorry, but I think is quite important. The object is when it's being called. So it is like the self or the.
Oh, I'm sorry, here. About this one?
It,
Okay, yes. It's, so for example, if you notice here, the ID is telling you it, column, person Kotlin, which is telling you that this sorted list is gonna give you each of one of those person Kotlin, and by default it's called it, but you can change the name of it. You can say person, and now it becomes person.
Okay, is the placeholder for each item from the list?
Yes, it's just a default name that it gives to an object that is presented inside of a lambda.
Mm-hmm. You can consider that thing like this in Java when you refer to something in this class, but I guess this is part of in this instance of the list, there is a couple items.
Yeah, yeah, exactly. And so after I show you that for lists, it's very idiomatic. You can just read the code and it tells you exactly what it is. And you don't need to check for the length of your list or anything. So that's part of the why it's very nice to read Kotlin, because you can just read it and understand what's happening without trying to understand all the boilerplate that we would have to do in Java. So even also debugging, it saves you hours and hours of debugging time.
You can even read it just like a script. I mean, you can just read the whole thing. It's like you have an idea what's happening without going into the weeds of the details.
Yeah, and to be honest, you don't even need to know the language very well. If you know Java, I'm pretty sure you understand what's happening here because it's simpler than Java. I think it will be way harder to go from Kotlin to Java than going from Java to Kotlin.
I agree.
Yeah, it will be extremely. One last thing that I want to show is extension functions. Extension functions are amazing, and they are overused, and you should not overuse them, but when you use them correctly, it's amazing. One of the things that extension function allows you to do is to add functions to objects that already are defined somewhere else without changing the code of that object. So for example, this first person object is right here. It comes from the person list, and person list, as we said, it has a bunch of persons Kotlin. So person Kotlin, that object, you see it right here, it doesn't have any functions inside of this type of object, right? But with extension functions, you can create functions for this type of object outside of that object. So let me give you an example.
Oh, wow. That's pretty impressive.
I added an extension function in which you say person Kotlin marries another person. This marry, I defined it on another file called extension functions. And I just say, create a function that for this type of object, this is gonna be the new, this is gonna be the new function name. This is gonna be my arguments, and this is what you're going to return. And after you declare this in this file, it doesn't need to be called this file, it can be any file you want. But after that, you can use this function on these types of objects anywhere in your code. So for example here, first person that marry last person. Now, your question here would be like, why not just add this marry function inside of the object, right? Because that function is pertained to that object. Well, the important thing here is that this object is on our realm. We created it, we can change it. We could add this function marry inside of here. But what if you are using objects created in another library that you don't have access to, you cannot change it? For example, Android, or when you use like a networking library, those come with their own predefined objects that you cannot add or take functionality out of it. But with extension functions, you can take those already created objects and give them certain functionality that they didn't have before.
It seems to be like it's similar to inheritance when you basically extends is redundant, right? But you extends a class and you have all the features of the superclass, but also you can customizable more depending on your need. Is it similar to that?
Yes. Actually, it is like that. And let me show you a quick example of how you can use that. So right now in our code, the fab is that button right here in the corner that you see. So it says in this fab, when you click on it, in this Lambda, execute this Lambda. This Lambda, we're gonna give you back that fab view. Everything in an Android app, everything that you see, it's a view. Everything, the view is the parent class and everything extends from it. So it gives you a view, and then we execute this snack bar. This snack bar is something that Android give us on their library. And what it is that when I click, you can see here at the bottom, a little bar that it shows and then it hides. That's a snack bar. And how you use those snack bars in Android, like out of the box, is like this. You say a snack bar, let's make a snack bar based on this view, which is gonna say this, and it's gonna stay this long, and then I'm gonna show it. This is the default way to do it. But if you say like, this is too much code, I don't want this. In Kotlin, you can change it. It doesn't have to be like this. So for example, you can change this with a extension function. So here in extension functions, I said like a view, which comes from the Android library. I wanted to have a new function that I just want to say show text, the text, and just show it. I don't care about anything else. And so now on my code here, I can get rid of this and just say this view that you passed to me, that show text. And that's it. We replace this whole line with just this. And what's gonna happen is the same thing. So basically, even if you're getting these predefined objects in your code, you can change how you use those objects in your code even. And you can create these extension functions to make all your life way easier and less boilerplate. And
a lot of
easier.
reusability. Yeah. A lot of reusability. I'm sorry to interrupt you. I didn't mean to interrupt you. I just want to say there's a lot of reusability. When you have that, you can save you dozens of hours just to try to do that thing. If you have something or a product or something that already is working with certain features, you can just use this wisely in case you know what you're doing.
Yep. So we're running out of time really quick. So I'm going to go back. This is the end of this little presentation of Kotlin, but I'm going to show you what's next. What's currently the most used things in Kotlin, what's happening in the Kotlin world, and yeah, well, what's the newest things, right? What am I using daily on my company and where we're trading for? So just to give you a little example of the taxonomy of a mobile app, independently of Android or iOS, you basically have these modules, starting from the left, which is where your data comes from, and then it ends on the right, which is the UI, how it's presented to you in your face, right? And that data that comes from networking or your database, it has to go through all this. This is just an architectural pattern. There's many of them, but this is just like an example of an architectural pattern that is used in mobile. So one of the problems right now is that if you notice all these modules, only the last two on the right, sorry, are related to UI. Meaning when you're touching UI, you're touching objects or libraries that come with Android or with iOS, depending which app you're creating. The business logic is basically just Java or Kotlin code, and you don't need to touch anything UI related or even anything related to Android or iOS. So currently, in most companies that have an app that is for iOS and Android, they have this architectural in every module created with their own language. In Android, it's either Java or Kotlin. In iOS, is either Objective-C or Swift. And if you see, we need to replicate the modules on each platform. And what we have done historically is that whoever is going to work on the repository in Android works along with the developer on iOS to create a repository. We create interfaces that are similar, and then we try to code it in the same way, but usually they're divergent because each Android and iOS have very different libraries. So what Kotlin comes to do, and this is the newest thing that Kotlin is introducing, they're introducing the Kotlin multi-platform concept. And Kotlin multi-platform, this last year in 2019, I went to Copenhagen to the Kotlin conference there. 85–90% of the talks there were about Kotlin multi-platform. And what is Kotlin multi-platform? Well, Kotlin multi-platform allows you to write your business logic, all those modules that don't touch UI, only in Kotlin. And then you can compile that to be used by Android or by iOS to different targets. This is huge because you write your code once, you test it once, and then you can use it on both platforms instead of having replicated code across your platforms. That changes how the whole economics of mobile development works in here in the Bay Area and in any other company. It's everything about money, right? And taking into account that each of these teams, the team in Android and the team iOS, it costs the company literally millions of dollars per year. If you introduce Kotlin, and then you can have one team only working on the business logic in Kotlin, and then just have a couple of developers who are really good with UI working on each platform, then you can reduce your number of team members and still have the same output that you had before with the same beautiful UI design that each platform provides the tools for you to create. And that's the reason why at the beginning I asked you, like, but why are companies investing in this Kotlin? Like, why are they changing their apps that were already in Java or already in Objective-C to Kotlin, right? And this is the reason, because it saves money for them. And we can reuse talent as well.
I think this model of what you just mentioned in the previous slide, is what revolutions the entire programming development and designers, and you just focus on Kotlin's programmers, and you just have a few Androids or iOS developers that just taking care of the user interfacing, and that will simplify in the industry. That will be, they will save them thousands or maybe millions of dollars just in hire them. Now you can see where exactly now, where is this focus for the new next day or then the next years, where is the main focus will be is in Kotlin, just to have more investment in Kotlin's programmers and have a couple of them in Android and iOS, because that will simplify, that will narrow down a lot of the process or hiring process and even the whole redundancy of code. Yeah.
And one last thing I want to touch. Sorry. Where is it? Not this one. No. Here. No. Give me 1 second. No, I lost my screen. Oh, it's here. Sorry. Oh, no. No, don't forget it. But what I wanted to mention is that right now, Kotlin you can compile Kotlin code to something that is consumable by Android or iOS, but you can also compile Kotlin towards web, JavaScript, or you can compile it to backend, so like C or other like Linux targets that are specifically for certain processors. So Kotlin right now is not only for mobile, they're working towards making one concise language that can be compiled to everywhere, backend, frontend, both frontends, web and mobile. And basically any other place. And that's what I see this future of this language going.
Yeah, thanks. Thanks a lot. I think it was very useful, very informative. Because as a matter of fact, I think that clear out a lot of the needs why people are so why a lot of industries paying a lot of interest in Kotlin these days. And let me real quick. That's great. And Kike, I have a couple questions. I think you answered most of the questions that we have in mind. But a couple questions that I received. This new languages, they seem to integrate all-in-one features for the cross-platform development, data science, and server development. Should young developers start learning Kotlin further as their first programming languages? So therefore, trying to jump the older programming languages like Java, C, C++, or should they look at the companies that they want to work and learn the programming or the tools that that company needs instead? I have that question from Mr. Sebastian.
So yes, definitely. This is the thing that I wanted to see. Definitely, you should learn Kotlin for sure, and this is gonna have a huge impact on a lot of enterprise. For example, here on the main kotlinlag.org page, the main page for Kotlin, it can tell you what it's good for. So mobile cross-platform, server-side, native, web development, data science, and Android. One of the things that I noticed when I moved when I got out of UTEP and I started getting my first job, if you notice, my first job was lead systems administrator, right? I was creating cloud systems in AWS, DevOps, basically. I didn't like it, and that's why I moved to Android. And I highly suggest to you that when you get out of college and you start looking for a job, it's probably that you're not like the first or the second thing that you do. I highly encourage you to find the thing that you like and then become good at it and go for it. Kotlin will help you with that, because if you learn Kotlin, then you can mobile, or you can do server side, or you can do native, or web development, or data science. So you're gonna have more options instead of trying to learn all the programming languages and everything that it's currently for each one of those places in development. Yeah. And where to learn it, I will go straight to the kotlinlab.org. You can try Kotlin right there and then online. You can create your things. Other than that, they have in Udacity, they have a free course for Kotlin. And it's created by Google, and the Google engineers, they put a lot of emphasis on showing you graphics, sounds. It's just when you see those videos, you're not even thinking you're learning. It's just it's fun to watch. It's nice.
Yeah.
And finally, the Kotlin Cons. Kotlin Cons, it's a set of exercises to start learning Kotlin. And if you go through all of these exercises, which are around 50, you can finish them in 2 days. You know most of Kotlin already if you go through that.
That's great. I'm gonna put that on the description of this video and this podcast. I have another question from Dr. Pano, who was not able to join us, but is it possible or recommend to use Kotlin for HPC applications?
High performance computing,
Yeah.
So in Copenhagen, one of the University of Texas high performance engineers, teachers were there in the conference and asked the same question. The answer is not yet. Not yet, because the engineers who are working on Kotlin, it's a very small group back there in around Russia or Ukraine, around there.
In St. Petersburg, I read, yeah.
Yeah, they're putting a lot of effort right now in the Kotlin multi-platform part of Kotlin, just because that's what right now is driving mobile development and is changing a lot of financially things for companies. So they're putting a lot of money there because obviously Google is injecting money to them. And for high performance computing, they're not putting a lot of, not putting enough effort, I say. They are working on that. That's what they said. They said that it's not going to be ready. It's not going to have the same performance as Java has right now until a couple of years.
So it's in the pipeline right now, but not right. Yes, yeah. So it's primarily because most of the mobile apps right now is the highly demand. But this, if this is possible to get the high performance computing aspect, then we can have a complete programming language there, as a matter of fact. So
yep,
that's good. Excellent. Any other questions? I think we have time for probably one or two more questions real quick. So I think these are great presentation. I want to thank you very much for making the time to come here and to come here to the podcast and talk to us about your experience as a developer, as a programmer, as all these different forms that you have been passing through your education and professional stages of life. I really thank you, Enrique, for joining us and for sharing this nice thing. I really hope to see you back later on in a different podcast or a different segment.
Thank you very much for the invitation. I enjoyed it very well. And if you have any more questions about Kotlin or just live in the Bay Area, or if you get out of college and you're looking for your first interview, just send me a text in LinkedIn and I'll help you out to go through that process.
Oh, wow. Yeah. Thank you for the offering. I want to thank everybody who showed up for the podcast and for your questions. And please stay tuned. We're going to have another podcast, not next week, but the week after. And stay tuned about the information. I will keep posting in the TheServinLab. In case you're interested, please stay tuned. Thank you very much, and I'll see you next time.